For those that don't know me, my name is Andy Hall. I'm a senior solutions architect with AWS. I've actually been working with Amazon now for this July, so in a couple of weeks it'll be 6 years. I've been in IT for 30 years, if not a little bit longer, so a very long time. So let's walk through this topic really quickly. So the agenda, first what we're going to do is we're going to take a look at the problem. Look at like what the problem set is in the entire space. We're going to dive into automated reasoning. I'm going to go over an example, and I know that I have resources called out here. I'm actually not going to go through those. I know that the slide deck will be provided after the fact, so you'll have all the links and everything, and that's really what the resources are if you care to dive into any of these topics even further. So it's broken up via AWS and scientific research papers and other studies and whatnot. So to dive into this, what is the problem here? Now, I'm sure, right, everyone's been playing around with LLMs and everyone's aware that LLMs themselves can hallucinate. And when we look at like that hallucination, it could be pretty egregious, right? There are times where it's extreme and it's really easy to pick it up, but sometimes it's actually very subtle. So in this particular case, in this example, on the left-hand side, this is, some human entered that text. And I'm asking an LLM, just go ahead and summarize it. And the other side of it is the LLM summary. I don't know if you guys can see, there is a hallucination in here. Can anyone pick it out? It's really subtle.
They're friends because they might be trade-offs of the algorithm, not themselves.
Nope. Yeah. You got it. Exactly. It is so subtle. Because models, they can hallucinate big, but they can also hallucinate small. We have these really subtle changes to it. Where we can see in this particular case, it just transposed the name Sam to Ben. That would be something so easy for us to miss. But when we think about last year, actually Gartner did a study for CIOs, and they call out hallucination for LLMs as the #1 issue, which I happen to agree with. There are other issues along with this, but hallucinations is the #1 thing that actually stops them from employing these systems, pushing them out in production, maybe even getting to the point where they're user-facing. But here's the thing about hallucinations. It's not a bug. In the context of LLMs, it's not a bug. It's actually a feature. And a little bit more than that, in fact, it's more than even a feature. It really, when we look at the model itself, that's actually its creativity, right? It's providing us creativity from this. And that, honestly, is the superpower of these things. So, in essence, we want them to hallucinate to a certain degree, because if we're going to get rid of that hallucination capability, and we're going to get rid of all that, we're doing is we're removing creativity from the model, right? We're removing that from the system. And at that point in time, well, why do we even really employ LLMs if you're going to get rid of all the creativity? So we know that hallucinations can happen in a subtle format, but we need to make sure that they actually still occur to a certain degree, so we have that creativity and use the creativity from the LLMs to help generate our answers. Now, for those of you that are in financial services and specifically life insurance, you might have heard of NIAC before. NIAC itself is not a regulatory body, but it is an organization of National Association of Insurance Commissioners. What they do is they help provide insurance commissioners of all the various states suggestions on rules or regulations that they might want to start to employ. And in fact, so NIAC actually released a statement. This was back in a bulletin, I should say, in December of 2023, where they call it specifically, when you're employing AI systems, what are the things that we actually should put some rails around, right? What should we put some guardrails around to make sure that your customers and your systems that you're using to support your customers, that they're operating appropriately. And that includes things like we want to make sure that decisions are being made, informed, and supported using AI systems. Okay, great. But we want to make sure we remove any degree of potential harm. We also want to make sure that we have transparency and explainability in our interactions. So so we have regulatory pressure, say from organizations to say like, hey, you should actually start to put some rules in place, and so that's happening in the industry. At the same time, this entire space around agentic AI is actually, and in AI in general, is moving really, really fast. So NIAC puts out their release back in December of 2021, December of 2023. In May of 2024, this idea comes out via scientific papers of like this guaranteed safe AI. And really what that means is there's a couple of different concepts that would be employed. One of them being like, we want this idea of a safety specification that applies like, here's some rules you need to operate by. That would include things like, you're not going to take direct actions that negatively impact customers, or you're not going to take actions that violate security policies. One of the other things that's actually kind of interesting is that you will not take actions that will actually move money on behalf of your customers. The other thing to call out in this particular case is not only the safety specification, but a verifier to verify that the agentic system itself is operating within the rules of the safety specification. So there's two components of that. Now, there's actually a branch of computer science mixed with mathematics. It's called automated theorem proving. This is actually, for those keeping score, this is actually something that's been around for a while. There was early attempts, I want to say it was in the early 2000s, to develop systems that would actually have this capability so that you can deploy it in your environment and prove on how things actually work appropriately. But at the core of it, we have the same concept, right? We have these solvers, and those solvers in turn are attempting to verify like a certain action happened, and can we say without a shadow of a doubt that that action occurred? And it really comes down to three main components, right? We end up in the case of like satisfiable, meaning like based upon all the conditions and understanding of what's happening in the space, yeah, we could satisfy that. You could also be in the case of unsatisfied, meaning like, well, maybe there's a mismatch in the data or something like that. You are looking for a specific aspect of it. Well, we can't satisfy it. And then last is like, we don't know. So if we group this all together, right, we have some regulatory pressure, we have a lot of the base mathematics and foundations that are being put together, and then we have additional scientific research that's happening on this front. This actually leads us to the concept of automated reasoning. So automated reasoning, when we really get down to the core of it, there's three main objectives that we're trying to achieve here. First one is we want to be accurate. We want to make sure that we clearly identify factual claims that are incorrect. Secondly, we want to make sure it's sound. And in the case of automated reasoning, really what soundness means is that we won't draw false conclusions from true premises. What that really means when we get down to it is like, we'd rather err on the side of caution. Like if we don't know, we're just going to say like, hey, it's unsatisfied. We're not sure. And the last aspect of this is transparency. We want to make sure that we can logically and verifiably explain why we believe something is correct. Where this really comes into play, when you think about it, is like if you are building agentic systems and you need to prove out why a decision was made and prove out mathematically to an auditor, this is exactly why, and then we could guarantee it is actually true, this is where automated reasoning comes into play. Now, automated reasoning itself, it is currently a preview feature of Amazon Bedrock guardrails. Really quickly, if you don't want to know what guardrails are, guardrails is a capability within Amazon Bedrock specifically to allow you to stop input to a certain LLM or prevent harmful output. So that could be, for example, like I want to avoid hate speech or explicit information or material. I also want to make sure, for example, like maybe I don't want to have PHI information or PII. Or I want to make sure that I don't answer questions about specific topics. Like I might not want my model to answer questions like what stocks I should invest in. Right? So we can limit that all through guardrails. And the capability that I'm talking about here is the additional functionality of automated reasoning, which ends up being a nice complement to guardrails. Now, automated reasoning is great, but it's not actually perfect in every single scenario. There are some cases where, yeah, we would actually want to do it, and there are other cases where it's not going to be a fit. Things that actually work for this are policies. Think of it as like, I have an employee expense policy, but it would be a great option for automated reasoning. You could also use it in the case of laws and regulations. Also, if you have operational workflows. For example, let's say you have a case, and I'll go through this a little bit in my example as we go through the rest of this deck. Let's say you have a process doc that calls out how you will actually process homeowners insurance claims. Automated reasoning would be a great option in this particular case to ensure that you are absolutely following those steps. Now, cases that it's not suited for, that would include things like marketing messages or generating best practices, not great for probabilistic calculations, like, what's the chance of something happening, or qualitative descriptions. Now, automated reasoning, let's take a look at like how this actually happens. The first step is you actually start with your source document, and that would be like like I mentioned, like it could be a policy or a procedure or something along those lines. Like we'll take the case of an employee expense policy. The policy itself is passed into the automated reasoning service, which then it can, the policy doc, sorry, and the automated reasoning will actually rip through that doc and create an automated reasoning policy. So from that policy, let's say now I did some interaction with an LLM and I want to make sure that I can then interact with this automated reasoning policy to make sure, yeah, mathematically this is actually the correct response that should be returned. So what I would do is I would send my information in through Bedrock Guardrails. Guardrails in turn would make a call back to automated reasoning, which in turn would then look at our policy, validate the information that was supplied in comparison to our policy, and return all that back to our user. And that would include things like, yeah, you're great, or the response of there are aspects to your input that are not factually correct, and here are the rules that you actually broke. So when we create an automated reasoning policy, there's a few pieces of data that we actually really need. Number one, obviously, is a name. You can name it really kind of whatever you want. The description, it's optional, but I'd recommend that you actually do just for an understanding of like where are you using this policy, how are you using it. And then you want to upload your content. Right now, you can see on the screen, there's actually a little warning note about like the size and the scope of the policy documents you could provide. That's because it's currently in preview. Once this becomes GA, that will change. But you can supply, like I said before, homeowners claims processing, employee expense process doc, whichever options you really want. The last thing I want to call on this page is that right now the intent says it's optional, but I would highly recommend if you're going to explore this feature, don't treat the intent as optional. Reason why is the intent is used to provide the system an understanding of what the doc is, how it should be used, and what sort of information you're going to try to compare it against. So I would highly recommend, this is usually at least 2 or 3 sentences where you want to fill out this intent. Once again, it's not required, but you actually have better generation of the policy doc if you do actually supply this. So we've gone through the process of let's go ahead and actually create a policy. What that really means is after we've given our document as the outline that has the procedures and processes, we end up with a creation of a couple different constructs. One of them is rules, and those rules are aligned once again back to a policy. And that would include things like like I mentioned, like a particular step of here's the things that we will accept. In this particular example here, I did this in the case of homeowners insurance claims processing. And what are, you can kind of see on the screen, it's a little tough to read, but here's some of the rules that would be generated from an example doc. That can include like what happens after a first loss of notice, what happens, like what are the acceptable damage types, at what point does an adjuster need to get involved into the overall process, that sort of thing. So those are our rules. And you have the ability to modify these. And I highly suggest, right, we want to make sure before we go ahead and release this policy out to the wild, that there is a review process. So you should be looking at it from an organizational perspective, let's review these, let's make sure they're correct. We can add additional rules if something's missing, we can remove them, we can also modify them as well. So on top of rules, you also have variables, and these can contain, specific numbers or facts, or it can include stuff like enumerated types. Like you could have like a property loss due to fire or something like that, or theft or something, other aspects of that. So you have your rules, you have your variables, and the last aspect is you have an ability through a playground to actually test these things. And generally, as people go through this process of, I have my doc, I've curated my rules, I'm going through all my variables, now I actually want to test things and validate, yeah, I'm actually good, before I go ahead and allow other people to use this. At the core of this, there is this idea, it's actually called semantics of propositional logic. For those of you that have been through comp sci before, you've probably seen tables like this. This is a basic truth table with different conditions, with ands, ors, nots, XORs, and whatnot, and how those different variables align to the operators in alignment with rules. At the core of it, when we look at like automated reasoning, this is actually what it's really doing for us, and it's building this up for us to do the evaluation of output from an LLM. As an example, here's a sample truth table that I have. We have 3 basic terms, and the idea here is like, how would I assess if someone is a good, acceptable risk if we were going to give them car insurance? So there's a couple of different variables in this mock scenario. Like I want to make sure you haven't had more than 3 accidents. You haven't had any DUIs. Also, your vehicle type is acceptable. Like we're not going to insure tanks, but sure, like a car is great, but we're not going to do any other things. So when we build that on up, our various terms, right? So we have chargeable accident account is less than 3, and the DUI count is 0, and our vehicle type is acceptable. Then at that point, we say, yeah, the risk is acceptable. This is an example of a rule using variables and how that relates back to the values of the various variables. So let's take a look a little bit deeper at another example here. So here on the right-hand side, I actually have an example doc for homeowners claims processing. Just to be clear, this is not any companies. I generated this. In fact, I used Claude to help me generate this. And so typing it up, it's about 4 or 5 pages long of the various steps. But in essence, it's relatively correct, right? What we're going to do is once again, we supply this document through automated reasoning to create our policy, which includes our various rules and variables, which can be seen on the right-hand side. Now, the next thing I need to do is I need to connect this with a guardrail. So in my particular example here, I actually went through and just created a brand new guardrail. You can take an existing guardrail and add it to it. Guardrails by default, they have some pretty good, some pretty good defaults are already set for like avoidance of hate speech and stuff like that. So the base information I'm supplying is not only the name, a basic description of the guardrail, and then I'm skipping all the way towards the end where I'm actually linking the guardrail back to my automated reasoning policy that was previously created. One of the things I should mention, when you have automated reasoning policies, you have the ability to version them, which is important. For example, like your process or procedure might change, that in turn would be another version. So you have the ability to pin your guardrail to a specific version to do some evaluation. Now, I have a test case here. I know it's a little hard to see from the screenshot. So on the right-hand side, this is the top part is the actual question I asked. So I had a fire in my house, and the fire department was there to put it on out. What do I need to do to file a claim? And the lower part is actually I asked this question back to Claude 3.5v2 in conjunction with using this guardrail. And the lower part was the response I got. And it covers, like, here's the various steps. This is, you need to contact your insurance company. Here's their, have your claim or have your policy number. Here, look at their 24/7 hotline. Make sure you document everything and whatnot. There's actually, the response is actually quite large. I think it's like another 7 or 8 steps. But when I run this through automated reasoning, I get 2 things. The first is, you can see at the top, I can satisfy that the answer returned from the LLM is absolutely factually correct. And the second part is, here's the proof for why it's correct, which includes, here's the various variables that I pulled on out, aligning to the rules that you supplied from your policy document that proves that the answer is absolutely correct. Now, great that we could do this from the UI, but there is, additionally, you can do this through Bodo 3 or other SDKs. Quick example here, in the case of Bodo 3, because it is linked back to the execution of a guardrail, for those that are familiar with Bodo 3 SDK and the various clients, this is actually the Bedrock runtime client that allows you to call directly to the guardrail APIs. The idea here is that guardrail itself, you can use it not only with LLMs hosted within AWS, but additionally external providers as well, if you wanted to. Anyway, so to call this, once again, I set up my guardrail. I went through and linked my guardrail back with my automated reasoning policy. And it's pretty simple, just a few lines of code to go ahead and execute my guardrail. Go off you go. This next chunk of text, really all I'm doing is I'm just processing the result. There's a few things that I want to call out here. So at the top of this, you can see the first if statement. You're checking to see, is there an automated reasoning policy in the response? And if so, let's go ahead and capture any of the findings. And from those findings, we could check and see much later down the code, about 3/4 of the way down, we can see for that finding, let's look at our result. And was it valid or invalid? And if it is invalid, let's go ahead and capture the rules on why it was considered invalid. And here's an example of, here is an example of what that output would look like from this execution of this code. By the way, this sample code is available for you if you're super interested. The link is included in the resources as well. You can see, right, I'm calling out the result as invalid. Here are the various assignments and suggestions, but specifically here are the rules on why it is actually invalid. This is hugely important when we go back to, for an auditor, prove to me why this is correct or incorrect. Why did you respond this particular way? Now, to wrap this on up, automated reasoning, brand new function features for Bedrock guardrails. If this is an area that you're particularly interested in, please reach out to me. Let me know. Actually have my contact info on this slide. Take a pic, reach on out. Would love to talk with you guys about this. I want to call out one last thing. This isn't something that's solely related to just financial services. This could be employed in a lot of different industries. It's just that I happen to focus on financial services. So if this is something you want to dive into, reach on out, let me know, guys. Thank you.